Number 4. Using f of x equals cosine of x as a guide, we want to graph g of x equals the secant of 4x. Identify the period and the asymptotes. So let's identify the period and the asymptotes first. So the way we calculate the period for secant, now keep in mind secant is the reciprocal of cosine, which is why we say to use cosine as a guide. But that also tells us how to calculate the period. Calculating the period for cosine is 2 pi divided by the absolute value of b, and that's the exact same way we calculate the period for secant. 2 pi divided by the absolute value of b, which in our case is 4. So that reduces to be pi over 4. Pi over 2. Now we want to calculate the asymptotes. So it's pi divided by 2 times the absolute value of b, which is 4, plus pi times n over the absolute value of b, which is 4. And that simplifies to be pi over 8 plus pi times n all over 4. Now, I'm going to use the cosine of x as a guide because if you remember, on number 1, we actually graphed 3 times the cosine of 4x. So we're going to use that to kind of help us do this one here because the reciprocal of secant of 4x would be the cosine of 4x. And so I'm going to graph the cosine of 4x first, and I'm going to do that in green using a dashed line for the graph, okay? So cosine of 4x is what I'm graphing next, doing it in green, and it'll be a dashed graph. I know it goes to the point 0, 1. And I know that between 0 and pi over 2, a full cycle occurs. So at pi over 2, I'm back at 1. So I know that I'm getting this pretty small looking graph here. And we actually went through and graphed part of this for number 1, except in number 1, when we graphed this, it had a vertical stretch of 3. So instead of being between 1 and negative 1, it was between, it was between 3 and negative 3. Okay, so using this as a guide, and I know mine's not the best graph because I'm trying to not make it too bold of a graph here because this isn't our final answer. This is just what we're using as a guide. Okay, so what I have in green, a rough sketch in green, is the graph of the cosine of 4x. Now we're going to graph the reciprocal of that. Now everywhere that this green graph crosses the x-axis is where there will be a vertical asymptote for secant. So anytime the cosine of 4x crosses the x-axis, I'm now going to have a vertical asymptote. So I'm going to do all of the vertical asymptotes in yellow. So vertical dashed lines that go through those points. So anytime that the green graph crosses the x-axis, I now have a vertical asymptote for the reciprocal function secant of 4x. And this graph, again, just like some of the other ones, is going to be quite small. So I know it gets a little hard to see, graph these when they're kind of, skinny, tight graphs. But do your very best, to get your points as accurate as possible. Okay, once you have the vertical asymptotes graphed, in blue, I'm now going to graph my final answer. Because any place where we have either a peak, such as at 0, 1, or a valley like right here, that's actually the either local minimum or local maximum for the secant of 4x. So now I have all of these parabola-looking shapes or curves that kind of flip-flop. When one goes up, the next one's going to go down. And we know where these parabolas, maximums or minimums are, is because that's where the peaks or the valleys were for the reciprocal function. And again, doing your best to keep the graph in between the vertical asymptotes. And yes, these are very, very skinny, tight graphs. I know they're not the easiest to do because they're pretty small, but do your very best to keep them as accurate as possible. Okay, and here is our graph of the secant of 4x.